Okay. Ate some Cheez-Its, so I'm powered up. I'm ready to go for part 2 of the study guide that you guys got before break. So this is going to be the sections on Unit 2 and Unit 3. All right, so it's saying use the following diagram for questions 9 through 20. We're given that A and B are parallel. That's a significant piece of information. Name all the vertical angles. So again, vertical angles we can think of as when two lines cross each other. The angles that are opposite each other are vertical angles. The formal definition has to do with two pairs of opposite rays. It's easier to remember two lines cross each other. Think of opposite sides. They're vertical from each other. So here we have 1 and 4 are vertical. So angle 1 and angle 4 are vertical. Angle 2 and angle 3 are vertical. Angle 6 and angle 6 and angle 8 are vertical. Interesting how they name that. Here they went 1, 2, 3, 4. Here they went 5, 6, 7, 8. Whoever made that diagrams. Interesting. Okay. So we had 6 and 8 were vertical. And then the last one is going to be 5 and 7 are vertical. Angle 5 and angle 7. Well, angle 5 and angle 7. Okay, number 10, name all the pairs of same side interior angles. So same side interior angles are on the same side of the transversal. So if we recall, we have two lines that are parallel, and then we have a transversal. Okay, so same side interior. So if we call this M, N, and T, T is our transversal. It's transversing the two other lines, cutting through the two other lines. Same side interior angles are angles, a pair of angles that are on the same side of the transversal. So either this side or this side. And they're interior. They're between the two parallel lines. They're in between the two parallel lines. They're interior. So here, right here, are two same side interior angles. Okay, we know they're supplementary, but that's not important for this question. Okay. So let's look and see where we have same side interior angles. Well, we have 4 and 6. Okay, they're on the same side. This is our transversal, A and B, and here's our transversal. Okay, same side. They're both on the top, above the line T, and they're between the two parallel lines. They're interior, inside the two parallel lines. They're in between A and B. So 4 and 6. Then the other ones are going to be 3 and 5. They're both below. They're on the same side of the transversal. They're on this side of the transversal. Okay, and then they're in between. They're interior to the two parallel lines. So this is going to be angle 3 and angle 5. Name all the alternate interior angles. Okay. So again, if we have our parallel lines and our transversal, alternate interior angles are angles that are on alternate sides of the transversal. So one's on this side, the other's on that side. And they're interior, meaning they're between. They're on the inside of the two parallel lines. They're between the two parallel lines. So here and here, or here and here. So alternate interior. So angle 3 and angle 6. And then angle 4 and angle 5. 6 and 3 are on alternate sides of the transversal, opposite sides, and they're in between the two parallel lines, so they're interior. The same is true for 4 and 5. They're alternate sides, opposite sides of the transversal. The transversal is the line that cuts through the two parallel lines, and they're interior because they're between the two parallel lines. 12, corresponding. So corresponding, so here's our lines, here's our transversal. Okay, if you pick up this point, you pick up this whole intersection, and you put it on top of the other one, the two angles that are on top of each other, or one is on top of the other, those are going to be corresponding angles because they're in corresponding locations. So you pick this up, put it up here, this one's in the upper right, this one is in the upper right. They're both in the upper right, those would be corresponding angles. Okay. This is in the lower left, this is in the lower left, those are corresponding angles. If you pick this up, put it here, they're in the same corresponding location, the same place. So let's find our corresponding angles in our diagram. So angle 1, what corresponds with angle 1? Pick it up, put it on top of this one. 1 is on the left side, so is 5. If you picked up this intersection and you put it on top of this one, 1 would be on top of 5, so 1 and 5 are corresponding. Angle 1 and angle 5 are corresponding. If you pick up the intersection and you're looking at angle 2, and you put it on top of the other one, angle 2 is going to be on top of angle 6. So angle 2 and angle 6 are corresponding. Same location, both on the top. Again, angle 3, pick it up, put it here. Angle 3 and angle 8. Okay, and then angle 4 and angle 7. They're both on the right. Okay, if you pick it up, put it on top. Which one's on top of the other? Same side exterior angles, so same side exterior angles. Here's our transversal. They're going to be on the same side of the transversal. Okay, but they're going to be outside, exterior of the two parallel lines. So same side, exterior. So we want to pick lines that are not in between the two parallel lines. So here is our two parallel lines, A and B. Okay, outside of them, so let's pick one that's outside, which is 1. Which is same side exterior with angle 1. Well, same side of the transversal and outside of the two interior angles, outside of the parallel lines, the only option here is 8. So angle 1 and angle 8. Okay. And then we have angle 2 is exterior. What is the other exterior angle that's on the same side of the transversal? It's going to be angle 7. Okay, so angle 2 and angle 7. Our last one is alternate exterior angles. Okay, so we want exterior angles between outside of the parallel lines, not in between, but outside of them. Here's our two parallel lines. So we want outside of them, not in between. Okay, so angle 1. So which angle is on the opposite side, exterior to the parallel lines? That's going to be angle 7. So angle 1 and angle 7. Okay. And then angle 2 and angle 8 are alternate exterior. Alternate sides of the transversal, exterior meaning they're outside of the two parallel lines. Okay. 4 linear pairs is the next question. And which ones are congruent and which ones are supplementary? So let's start with the linear pairs. It wants us to name 4 linear pairs. We can just name all of them. So angle 1 and angle 2. This is for 15. Angle 1 and angle 2. Angle 2 and angle 3. Well, I'm just going to write up here to have more room. It's going to be up here. Angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4. Well, again, they jumped out of order. Let's think about what we're doing. Angle 1 and angle 2. Okay. Angle 2 and angle 4. Okay. Angle 4 and angle 3. Angle 3 and angle 1. Okay. Remember, a linear pair are two angles that are supplementary and adjacent. So they form a straight line. They are adjacent, they're right next to each other, and they're supplementary. So that means they form a straight line. So 1 and 2 form a straight line, 2 and 4, 4 and 3, 3 and 1. They're both adjacent and supplementary. We could also look at the other intersection point and do angle 5 and angle 6. Form a straight line, they're supplementary. Angle 6 and angle 7 are a linear pair. Angle 7 and angle 8, and angle 8 and angle 5. Which of the above types of angles are congruent and which are supplementary? Let's just write them in up here. Alternate versus vertical angles are congruent. Always congruent. Same side interior angles are, and this is the case for if A is parallel to B. So if the two lines are parallel, then we can say it about these 5. Okay. Okay, so same side interior angles are supplementary. Okay, alternate interior angles are congruent. Corresponding angles are congruent. Same side exterior angles are supplementary. Alternate exterior angles are congruent. And then linear pairs are always supplementary. So linear pairs are always supplementary. Vertical angles are always congruent. If the lines are parallel, then the same side interior angles and the same side exterior angles are supplementary, and the alternate interior and alternate exterior and corresponding are congruent. 17, we have 17 and 18, we have some proofs. Okay. 19 and 20 look like there's if blank and blank, yeah, it just didn't copy over. Okay, that's fine. Okay. So we have a guided proof here. Okay. So let's scroll up a little bit so we can see the top, or down so we can see the top. It says that given that A is parallel to B, so we're going to still use the diagram from the top. Okay. If A is parallel to B, prove that the measure of angle 1 plus the measure of angle 8 equals 80. So our first step is to write our given. So A is parallel to B, which is given. I wouldn't worry too much about the proof like this, but 5 and 8 is 180. Okay. So if we scroll up and we look at our diagram, 5 and 8 are a linear pair. Okay. We know linear pairs are supplementary. So we know the measure of angle 5 plus the measure of angle 8 is 180. That is a linear pair theorem, or definition of supplementary. I don't like a proof like this because it's really leaving out steps. I wouldn't worry too much about these. So we have angle 5 and angle 8 add up to 180. Then it's saying corresponding angles of parallel lines are congruent. So we're looking for corresponding angles. We're probably looking for an angle that is corresponding 1 and 5. So let's see, are 1 and 5 corresponding? Yes, they are. So we can say the measure of angle 1 equals the measure of angle 5, because corresponding, again, this is equals, not congruent. So you're leaving out steps. You're not being very precise. You're not giving a good justification. You're giving a explanation more than a justification. I wouldn't worry about these proofs too much. Okay. Then we can use substitution. Okay. So instead of putting the measure of angle 5, right, we can substitute in the measure of angle 1. So the measure of angle 1 plus the measure of angle 8 is 180, and that's by substitution. Okay, number 18. Given that A and B are parallel, prove that angle 3 is congruent to angle 6. So we want to prove that angle 3 and angle 6 are congruent. So we have to use we can't use alternate interior angles because that's what we're trying to prove. So we're going to have to say something like corresponding angles are congruent. And then we can do vertical angles are congruent, something of that nature. So let's start with our given, which is that A is parallel to B. That is our given. And then we know, okay, we want to prove 3 is congruent to 6. So our methodology, we want to start with 3. So let's start with the measure of angle. Okay, well, so again, I don't like how this, okay, let's use angle 3. Well, yeah, okay. Measure of angle 3. I guess we got to use the measures. So we want to start with angle 3, and we want to get to 6. So what do we know 3 is congruent to? We know 3 is congruent to 2, and we also know 3 is congruent to 8. So it's congruent to angle 2 by the vertical angle theorem. It's congruent to angle 8 by corresponding angle theorem. So let's go with the corresponding angle theorem. So let's say the measure of angle 3 is equal to the measure of angle 8. Or we could say angle 3 is congruent to angle 8. Let's do that. I like that better. I think that's what they intended, but let's do it the better way. So we know angle 3 is congruent to angle 8 by the corresponding angle theorem, which says if the two lines are parallel, then the corresponding angles are congruent. So since A and B are parallel, and angle 3 and angle 8 are corresponding angles, angle 3 and angle 8 are congruent. Okay. We also know then that angle 8 is congruent to angle 6 by the vertical angle theorem. Okay. And then, as we've done all along, we can use the transitive property. Of congruence. Okay. Transitive property, since angle 3 and angle 6 are both congruent to angle 8, we can say that they're congruent to each other. So angle 3 is congruent to angle 6. Okay. And this is what the proofs we've done look like. Okay, but they're asking for one more step. They want to prove that the measure of angle 3 see, the question's not even good because let's just get rid of the measures. Angle 3 is congruent to angle 6. We could say the measure of angle 3 equals the measure of angle 6. We can't say the measure of angle 3 is congruent to the measure of angle 6. So That's the type of proof we're looking for. Okay. So I like this one better than, like 18 better than 17. I wouldn't worry too much about 17. Worry more about 18. Okay, 19 and 20 are cut off. We don't know what they say. If blank and blank, solve for x and find. Yeah, so can't do those because they're cut off. All right. So I'm going to stop this and do a third video for unit 3.